Let's take a look at the second derivative test. This is really nice for determining local mins and maxes. So you can think of this as a second derivative test as it relates to local mins and maxes. So let's let f be a function such that the first derivative at some value of c is 0. So in other words, c is a critical number of the first derivative. And the second derivative of f is continuous on an open interval about c. So there I have a critical value here. This is a candidate for a local min or max based on the first derivative. And I know that the second derivative, f double prime, is continuous on an open interval about c. Then I have a couple of scenarios I can look at. If the second derivative of c is greater than 0, then f of c is a local min. Well, that kind of makes sense because think about this. If I have a local min, so right here I have this critical value, right, from the first derivative. If the second derivative is positive, that means the first derivative is increasing throughout this interval, which it is. See, the first derivative is negative, then it's going to 0, then it's getting bigger, so it's increasing throughout this interval. That means that this critical value is in fact a local min. Now you probably imagine what's going to come next. If the second derivative is less than 0, then f of c is a local max. And by the same argument, again, that makes sense. So let's just make a local max. There it is. Here's this critical value, and the first derivative is going to be decreasing. See, it's positive, it's getting smaller but positive, it becomes 0, and then negative, so clearly it's decreasing over this entire interval. So if the second derivative is less than 0, that means the first derivative is decreasing. So that's just another way of checking it. And the last we want to take a look at is if the second derivative of c actually equals 0, then the test, the second derivative test, is actually inconclusive. So you need to use something different, like perhaps the first derivative test. So in a nutshell, there is a second derivative test. We take the first derivative, find the critical values, take a second derivative, evaluate the second derivative at the critical values from the first derivative, and from that we can tell whether we're dealing with local mins or local maxes.